Hey y'all, it's Miss Johnson. I got my video stuff working again, so here's a video. Okay, so the first video we're gonna do is from the assignment from 21. Oh, well, let me actually do it like this. From 222 on Monday, right? I'm gonna run through a couple things here, and then the assignment from today is 225. We did these two in class. I'm gonna do them again on the video just in case you want to walk through them again. And then your homework is doing these two examples, right? And I'll give you a couple pointers on those as well. All right, let's get going. I wrote this a while ago. I think I don't want to do exactly the ones that I said. So let me take a quick look and make sure we're doing the ones we want to do. Okay, so your assignment on Monday was to fill in the rest of the angles in this diagram, right? Fill in A through O and justify, like prove why they are what they are. So we'll do A, we'll do M, we'll do D, and we'll do let's not do M. Let's do O. We'll do D, and we'll do F for our examples that we'll do on the actual thing. So A, I think we said this in class. If we're looking at A, the only one we know around it is 57. So we're going to zoom in on this and only care about this crossing, not the rest of the diagram. And we're going to say A and 57 are across from each other. We call those vertical angles. Vertical with 57. And that means A is equal to 57 because vertical angles are always equal to each other. And that's good. We can write exactly that, and that's full credit, right? And then for O, if we're looking at O, we can say, okay, well, we know 57, but we also now know that A is 57. So we can use this information as well. And this is going to be the key one because A and O are corresponding. And corresponding here has a specific meaning, corresponding with A. And the specific meaning is that if you copied and pasted this crossing, it fits perfectly over here because these two lines are parallel, right? And because it fits perfectly, that means O and A are equal. 57. All right, this is the wacky one. We did talk about this in class, but I'm going to talk about it again. When we're finding D, we're not going to use vertical angles, linear pairs, or corresponding angles. We're in fact going to use that the angles in a triangle all add up to 180, right? So we're going to say that, where is it? Over here, D, the angles of a triangle, which are 40 plus 57 plus D, all add up to 180, right? And when we do our algebra 1, we get that D is equal to 83. Yeah. And then the justification is angles in triangle add to 180. Perfect. And then the last one we're going to do as in the video is F. If we already know that D is 83, F is right next to D, right? It's right next to D. The angles form a straight line when you put them together. So F and D are linear pairs. Which means that when you add them together, they equal 180. So again, for F, we would do 180 minus 83. 97. On the notes that I'm going to post from this video, you'll have a justification word bank. You can use basically these things in quotation marks as your justifications, right? And I'm giving you an example of one of each of them. To fill in the rest of these, you just think of this as its own parallel line cut by a transversal diagram. You can zoom in and think of this as its own parallel line cut by a transversal diagram, right? And then we will use vertical lines, corresponding angle, or vertical angles, corresponding angles, and linear pairs to justify the rest of those. All right, get to good. I'm going to switch over to today's, and I'll put the timestamps in both of these so you can watch which half of the video you want. No, I'm actually just going to cut it here. I'll start a new video. All right, y'all. That was the video for Monday. Go team.